take a look at graphs of exponential functions. So first of all, what is an exponential function? Well, it has the form y equals a times b to the x. So something that should stand out to you is that the variable x is in the exponent. So exponential functions have the variable in the exponent. So a and b are constants. Let's first look at ones when a is 1. So we really just have b to the x. Okay, and for demonstrative purposes, let's say y equals 2 to the x is the function we're going to look at. So b is 2. Alright, let's look at some specific points. First one I want to point out is when x is 0. So when x is 0, you have 2 to the 0, and anything to the 0 power is 1. So in this case we have 0, 1. Alright, now the next point is when x is 1. So we have 2 to the first, which is just 2, this number. So when x is 1, y is 2. Okay, but this is definitely not going to be a straight line, and you'll see that right here. When x is 2, we have 2 squared, which is 4. So it increases at a much higher rate. And now you'll see when we go to the next number, it's going to jump even more. So when x is 3, we have 2 to the third, which is 8. So when x is 3, we have 8. So you see it curves up drastically. Alright, what about when x is negative 1? So let's take a look at this. That would be 2 to the negative 1, which is really 1 over 2 to the first, or more simply 1/2. So we see it still continues to go downward here. Then when x is negative 2, we have 2 to the negative 2, which is 1 over 2 squared, which is 1 over 4. So now this goes down to 1/4. This is going to continue like this, and in this form it's never going to go below x. It's never going to be negative, because even though these numbers are negative, it's just changing the exponent of the number in the denominator. So this is the basic graph of an exponential function. So this is the graph of y equals 2 to the x. Let's see what the graph of y equals 3 to the x would look like. So put some of the same points here. And we'll start with 0. We put 0 in. 3 to the 0 is going to be 1. So this is just 1. When x is 1, 3 to the first is 3. When x is 2, 3 squared is 9. And when x is 3, 3 cubed is 27. So we see these numbers grow much more quickly. And it'll be even more evident when we graph it. So 0, 1. So same point here. 1, 3. It's already past it. 2, 9 is much higher than this previous one, even higher than the next point, and then 327 is going to be off the graph. So it gets very steep very quickly. Now with the negatives, 3 to negative 1 is going to be 1 over 3. So this would be 1/3. And then 3 to negative 2 is going to be 1 over 3 squared, 1/9. So on this side, it's actually gets smaller more quickly. Then past 0, it grows more quickly. But still, it's not going to go below the x-axis. So this one is y equals 3 to the x. Okay, now let's take another graph and compare it to y equals 2 to the x. Let's graph y equals negative 2 to the x. I'm just going to change the x values a little bit. So again, let's start with 0. When x is 0, we have 2 to the 0, which is 1. And then, let's go all the way down to negative 3. 2 to the 0, which is 1. Then negate that, we have negative 1. So 0, negative 1, 0, negative 1. When x is 1, 2 to the first is 2. Then negate it, we have negative 2. When x is 2, 2 squared is 4, so we have negative 4. Then when x is 3, 2 cubed is 8, so we have negative 8. So 2, 4, 3, negative 8. So if we look at it, we see that it's a mirror image of this reflected over the x-axis. So we put negative 1 in here. We have negative 2 to negative 1. So negative 1 over 2, negative 1 half. And if we put negative 2 in here, we have negative 2, or negative 2 to the negative 2, which is negative 1 over 2 squared, negative 1/4. And we put negative 3 in, negative 2 to the negative 3, negative 1 over 2 cubed, which is negative 1/8. And it'll be like really close to the line, so we have a graph like this. So a negative is going to reflect it over the x-axis. Let's look at another one in relation to this. So instead of y equals 2 to the x, y equals 1/2 to the x. Alright, so now let's put our numbers in. Negative 3, negative 2, negative 1, 0, 1, 2, 3. That would be our x, and let's find out what y is. So let's start with 0 again. So 1/2 to the 0 is going to be 1, because any number raised to the 0 power is 1. Let's put 1 in. 1/2 to the first is just going to be 1/2. 1/2 to the second power is 1/4. 1/2 to the third power, so 1/2 to the third power. Each of these gets raised to the third, and we end up with 1 cubed, which is 1, and 2 cubed, which is 8. So 1/8. Now let's go backwards. 1/2 to the negative 1, which is the reciprocal of this, which is 2. Okay, 1/2 to the negative 2. 1/2 raised to the negative 2. So the negative means reciprocal, so we really have 2 over 1, or just 2 squared, which is 4. And then same thing here, 1/2 to negative 3. The negative means due to the reciprocal. So this is going to end up being just 2, but cubed. So we change that to positive, which is 8. Alright, so now let me just erase some of this. And now let's graph these. So negative 3, 8. Negative 2, 4. Negative 1, 2. 0, 1. 1, 1/2. 2, 1/4, and 3, 1/8. So when we graph this and compare it to y equals 2 to the x, you see that it's actually reflected over the y-axis. So if we take y equals 2 to the x, which is this one, and instead of using 2, use the reciprocal, 1/2, we get a reflection over the y-axis. So think about this logically. If we have an integer greater than 1 raised to the exponent, it's going to constantly increase on this side when exponent is greater than 0, because you're multiplying it by itself over and over again. So you have 2, multiply it by 2 again, then you're at 4, multiply it by 2 again, you're at 8, multiply by 2 again, you'll be at 16. Whereas with this one, we have a fraction less than 1, but positive raised to an exponent. So you start off with 1/2 right here. Then you multiply that by a half, so you got a fourth, even smaller. Multiply that by a half, and you go down to an eighth. So if you have a base that's greater than 1, it's going to grow rapidly. If you have a base that's less than 1 but positive, it's going to decrease or decay rapidly.